Astronomers around the world are sounding the alarm, not because of an asteroid on a collision course or a comet suddenly brightening, but because of something far more perplexing. Something so gigantic and so unusual that even the most seasoned researchers admit they have no idea what they're looking at. It started as a faint, inconsistent signal near the boundary of the heliosphere, a place where the sun's influence weakens in interstellar space begins. At first, the anomaly was dismissed as noise in the data, the kind of interference astronomers see 100 times a night. But then, the signal returned, stronger, clearer, and accompanied by a reflection pattern that couldn't be explained by anything we've cataloged before. When observatories combined their data, the picture that emerged was astonishing. A massive interstellar body, far larger than Oumuamua, darker than any known comet nucleus, and traveling at a velocity that made even Neptune's orbit seem painfully slow. This was no ordinary visitor from another star system. The first estimates indicated a size that shocked specialists, somewhere between 150 and 300 kilometers across, large enough to qualify not only as a dwarf planet, but possibly as the fragment of something even bigger. But size wasn't the issue. It was the behavior. The object wasn't tumbling chaotically like natural debris. Instead, it rotated smoothly, almost rhythmically, as if locked in a controlled spin. And then scientists noticed something deeply unsettling. The object had begun accelerating, not by much, just a fraction of a percent, but enough to eliminate every natural explanation. No gravitational slingshot, no solar radiation pressure, no outgassing jets. Something was pushing it, or pulling it, in a way that defied the ordinary physics of interstellar wanderers. When the James Webb Space Telescope captured its first infrared profile, the mystery deepened further. Instead of a cold, dormant rock, Webb detected subtle but precise heat signatures spaced across its surface, patches warming and cooling in a repeating pattern, almost like the pulses of a dormant engine. But the most shocking discovery came days later when new data revealed that the object's trajectory was shifting, not randomly, but deliberately, aligning itself with the ecliptic plane, the thin, flat disk in which nearly all planets orbit. Astronomers were left with a chilling question. Why would a gigantic interstellar body adjust its course toward the very region where the solar system's planets reside? As the object moved closer, more observatories began to pick up details that didn't fit any known natural category. Its surface was irregular, but not in the way typical asteroids are. Instead of chaotic fractures, it displayed long, linear structures, geometric ridges extending for dozens of kilometers. These ridges reflected sunlight differently from the rest of the body, producing bright glints that suggested metallic content or organized layering. Under magnification, these structures were too straight, too consistent, too engineered-looking to dismiss as random geology. And then the thermal signature changed again. Instead of isolated pulses, the object began emitting heat in bands, broad, sweeping zones that wrapped partially around its surface. It was almost as if an internal mechanism was slowly activating. Researchers tried to explain it as sunlight warming the object unevenly, but the timing didn't match. The heating was periodic, not dependent on orientation toward the sun. Even more confusing were the spectral signatures, traces of elements rarely found together in natural celestial bodies, including unusual nickel-iron composites and hints of high-density alloys yet to be identified. Meanwhile, data from the Deep Space Network revealed another twist. The object was interacting with the solar wind in a way that resembled shielding. Instead of scattering particles randomly, it was deflecting them in predictable arcs, creating a kind of aerodynamic slipstream, something no comet or asteroid has ever been observed doing. While all this was unfolding, astronomers ran simulations to estimate its path. The results were shocking. If nothing changed, the object would pass directly through the inner solar system within the next few decades, skimming between Mars and Earth at a distance close enough for high-resolution imaging,
Not so close as to be dangerous, but close enough to provide a level of detail we've only dreamed about when studying interstellar bodies. The scientific community split into camps. Some insisted it was a bizarre natural formation, the product of extreme conditions far beyond our star. Others suggested it might be a fragment of an alien superstructure, a broken shard drifting for millions of years. A few whispered about the possibility of an ancient probe, one that might be reactivating as it encounters sunlight for the first time in eons. And while speculation grew, one fact overshadowed everything else. The object continued adjusting its trajectory, as if aligning itself with a predetermined path.
When the object reached the outer regions of the heliosphere, sunlight finally illuminated its full structure, and what researchers saw left them speechless. The dark, irregular mass revealed massive plateaus, angled surfaces, and deep cavities that appeared carved, not shattered. One region displayed a near-perfect hexagonal indentation, big enough to swallow a city. Another area reflected light as if coated with a metallic sheen, shimmering against the solar backdrop. But the most extraordinary discovery came when radar scans detected hollow spaces inside the object, vast chambers stretching hundreds of meters across. Natural voids do exist in comets and asteroids, but not with walls as smooth and consistent as these. In fact, the internal geometry resembled tunnels or compartments, aligned in patterns too uniform to be random. As the object drifted deeper into the solar system, something else changed. The heat patterns intensified, becoming more organized, flowing across the surface like waves of thermal activation. Even the rotation of the object began to shift, subtly adjusting itself as solar radiation increased. To many astronomers, it looked like the object was responding to the sun, almost waking up from a long dormancy. The idea seemed absurd, yet no better explanation surfaced. Furthermore, the object's faint electromagnetic emissions began to fluctuate. These signals weren't strong enough to classify as communication, but they were structured, repeating in cycles that matched the thermal pulses. Meanwhile, on Earth, agencies debated how to prepare. Should probes be launched? Should a monitoring station be constructed on the moon? Should the object be considered a threat? The public was unaware of most details. Official statements remained vague, talking only about a large interstellar visitor with unusual properties. But inside conference rooms, the tone was far less calm. The object was enormous, accelerating, heating, resonating, and adjusting its vector. None of these things pointed to a passive chunk of rock. And if it wasn't passive, then what was it doing? One hypothesis gained quiet traction. The object could be a fragment of an ancient technological structure designed to activate when approaching a star. Another theory proposed it was a massive scanning device, retrieving data as it moved through stellar systems. But the most alarming possibility was that it wasn't drifting by chance. It was following a route. If projections hold, the object will pass through the inner solar system at a distance so close that humanity will obtain the most detailed interstellar observations in history. Every major telescope, on Earth, in orbit, and on the Moon, will be pointed at it. The James Webb Telescope will capture infrared maps of its surface, while solar probes will measure the way it interacts with radiation. And if the object changes course again, even by a fraction, we'll know instantly. But the closer it gets, the more urgent the questions become. What is powering the thermal pulses? Why does the object rotate with such precision? Why is it emitting structured electromagnetic fluctuations? And what lies inside those massive internal chambers? Some experts say this could be the greatest scientific opportunity humanity has ever encountered, a direct look at an object that predates our solar system, possibly tied to a lost civilization or unknown cosmic phenomenon. Others warn that we must prepare for the unexpected, because if the object is not natural and every indication points in that direction, we cannot assume its behavior will remain passive. For now, we watch, we measure, we calculate. But one thing is unmistakable. The universe is far more dynamic and far more populated with mysteries than we once believed. The arrival of this gigantic interstellar body is a reminder that the solar system is not isolated. It's part of a vast galactic highway where objects, structures, and perhaps even technologies drift across the stars. As it enters our cosmic neighborhood, humanity stands at the threshold of a discovery that could redefine our understanding of physics, engineering, and life itself. Whether this object is a relic, a machine, a fragment, or something entirely beyond our imagination, its presence is undeniable and its approach is inevitable. The countdown has begun. Astronomers are alarmed. The world is watching. And the moment this colossal interstellar body enters the inner solar system, everything we think we know about the universe may change forever.